Oh, my bad.
Okay, so calculate the number of weeks in 672 hours.
The number of weeks.
Dr. Henry, those are not the kind of problems I think I'm having issues with.
All right.
What was that?
I said, those are not the kind of problems I think I'm having issues with.
Yeah, that's all right. Don't worry, I will build you up.
Oh, okay, okay.
Okay, promise.
Okay.
Okay, so we have 672 hours. How can I change hours and I want to calculate number of weeks? So what are my conversion factors?
Minutes?
Hours.
24 hours in a day,
So we have 24 hours in a day.
7 days in a week.
Seven days in a week. Okay, so this is my given. So I always want to start off with my given, right? And then I want to figure out exactly what I want. I want weeks, right? So I'm going to put weeks over here. That's the goal. So then, because these guys are equivalencies, I can kind of flip them any which way I want to flip them, right? I could put 24 hours over 1 day. Or I could put 1 day over 24 hours. Okay. So since I can flip them any which way I want to sit there and set them up so that I can cancel out units. By canceling out units, it'll allow me to get to where I want to get to. I want to go from hours to weeks. So if I did that, which one am I going to use? This one or this one? A or B?
A.
A.
Okay.
A.
1 day, 24 hours. Okay, so then that'll allow my hours to be canceled out, and now I'm left with days. So then I know that there are, like you just told me, I have 7 days in 1 week. So am I going to put day on the bottom, or am I going to put weeks on the bottom?
Days in the bottom.
In the bottom.
Going to put days at the bottom. And then, oops, 7 days, 1 week. Okay, so then all I'm going to do is multiply everything that's on top. I multiply that all together, and then I divide all by the things that are on the bottom. Or if you're kind of creative, you can multiply everything across and then do your division afterwards. Both ways should work. So that gives me 4 weeks.
Yes.
Good. Okay, now I have a serious question for you. Okay, so I'm going to tell you this, and I want you guys to put it somewhere in your head and also write it down on a piece of paper somewhere.
Okay.
Okay.
Yeah.
So, how many Sig Figs should I have? So I'm going to tell you something. I think I've said this before, but I'm just going to verify it. I'm going to tell you now so that you kind of ingrain it in your head. Equivalencies or conversion factors, we don't use those to determine significant figures. Okay. So we never use equivalencies or conversion factors to determine significant figures. So then, how many significant figures, right, should I have for this problem?
Three.
3.
That is right. So then my answer should be
Okay.
3 figures.
so it should be what, 4.00?
4.00.
Is that 3 significant figures?
No,
No.
that's not.
Okay, Mary, you want to put $100 on that? I need to make some extra cash.
Okay.
right? Remember, what does that decimal point mean?
It means the zeros stay.
That means the zeros are going to be significant, right? So because I took that extra time to put that decimal point there, the zeros following that decimal point are going to be significant.
Okay.
Right? Remember,
Yeah.
we're lazy. That's right. Yuri.
Yeah.
Okay. So anytime that you're putting extra effort into it, that probably means it's going to be significant. Okay.
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 Got it. Yeah.
Okay, good. And somebody's going to ask me, so Dr.
Yeah.
Henry, when do I need to use significant figures? Is that what somebody's going to ask me? I know Nate was going to ask me that. I'm just reading his mind already.
No,
I was going to ask you that too.
I was going to ask you if it was, for example, 40.00, like the zero before the decimal point, is it also significant?
Yes, if you have 40, let's say
Okay.
we had 40.00,
Yeah.
yes. So that number would be significant as well. Anytime that you're putting a
Okay.
decimal point there, that means it becomes significant. If I just put 40 with a decimal point, that's significant.
Okay, so if there was no decimal point, if it was just 40.
Then you only have one significant figure.
Okay.
Yep.
Okay, so now as for 40.00, that means the zero before the decimal point and the zeros after are all significant.
That is correct.
Okay.
Questions, concerns, cash. Did
Oh, but
somebody
so hey, I'm interested in making extra cash. How do I do that?
make some extra cash?
Yes.
There's always ways.
Okay.
We can discuss that later.
Okay.
And of course, they're all legal. Okay, somebody put this one on my board.
Okay.
Aaron, are you trying to give me a hint?
A hint? No, I was just wondering if you could cover this because I actually showed this problem to my father, who's a nurse, and then I sent it to my friend whose mother is the head nurse here at the state hospital, and she couldn't get it. My dad couldn't get it. I don't know how to do this. All the questions that you gave us for the homework, it was difficult, but I solved it.
Okay.
But this one is, it's so hard. I couldn't even understand. I can't even understand it.
Okay.
So I was hoping you could help with this and I could show the answer to my dad.
Yeah, I love problems like this because they're fun. They're like puzzles, right? So let's figure out what it is that they're asking us to find. And we're given here, the reason why it's always so difficult and it drives people crazy is because there's so much information that's being provided, right? So let's start off with a couple of things first, and then there's going to be a couple of things that we need to also take into consideration. First thing is, what are we looking for?
How many kilograms are going into their system per minute?
We want to know how much of the drug, which is going to be in micrograms. So that MC, this is just another abbreviation for micrograms. MC also means
Mu?
this is mu G, right? So 1 MC, and so that's just micrograms. They're both abbreviations for micrograms. In the US, we use MCG because nobody knows how to find that funny looking U thingy. And so we often will just use MCG to make it simple.
Does MG mean MCG?
No, MG does not mean MCG. MG means milligrams. And so you don't want to mistake MCG for, because they're completely different from each other. Milligrams. They're a factor of 10 to the third different from each other. Okay, so we want the MCG. So we want to know how much the drug per kilogram the patient weighs, right? and then that's per minute. Okay, so we want to figure out how much of drug are we giving per minute to a patient that weighs a certain amount of kilograms. That's what this figured out. Okay, so our goal is to try to get micrograms per kilogram per minute. Okay, so what's given to us? What are some of our givens?
The patient weight.
135
The
pounds.
weight, 5 pounds.
So we're given the patient's weight. So we know that one patient weighs 135 pounds. We know that it's one patient. So let's go ahead and say, if you look at this, at the units just alone, looking at the units alone, this is what we're seeing. We're seeing micrograms per kilogram per minute, right? So kilograms is what, it's a heavier weight. Micrograms is a very, 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 very small weight. So that kind of tells me immediately that we're talking about the drug when we're talking about the microgram, and we're talking about the person when we're talking about the kilograms, right? And so sometimes you got to use a little bit of, let's say, common sense, right? Because you know you're not going to give a person a body weight of drugs, right? So you're not going to give somebody, 100 kilograms of drugs, are you?
No.
No, right? So you can imagine, it's like, here, I'm going to give you 100 kilograms of meth, right? You kill the person, right? So you're not going to do that, right? So when you're thinking about kilograms, you're thinking about probably body weight or like a truck or something like that. You're not thinking about, a little bit of drug, okay? So in the case of micrograms, right? You're never going to weigh somebody in micrograms because, man, that number is going to be so huge, right?
Yeah.
So you know that you're going to use that micrograms for something that's going to be very, very small, okay?
Yeah.
Okay, so let's use it a little bit of common sense, and that'll kind of help us organize our questions. So we have a mass on the bottom, and we also have a mass on top. This mass on top is going to represent our drug. So how can we start off with getting our drug on top? So let's read the question. It says, a patient weighs 135 pounds and is receiving a medication via IV, and then this is the infusion rate of that IV. So the drug that they're getting is going to be coming in at 600 milligrams per milliliter. Oh my gosh. So that's my drug, right? So, and that's a mass. Is it milligrams mass?
Yeah.
Yeah.
Ah, so I could probably start off with something like that to kind of get me to my mass. So 600 milligrams. And it's at 600 milligrams per 500 milliliters. Okay, so then it also says that this infusion is at 20 milliliters per hour. Oh, wait a minute. Is it hour time?
Yes.
Yes.
Ah, and this unit down here is also time. So I want time to be at the bottom. Is that correct?
Mhm.
Right? So then I could sit there and use that as well too. So I could say, oh, 20 milliliters per hour.
Yeah.
Okay, the last thing is I have to come up with some type of weight, right? Well, I know how much the person weighs, right? How much do they weigh?
135 pounds.
So one patient, so we're just going to use the number 1, representing that patient, weighs 135 pounds.
Yeah.
Okay, so then that is that other mass, that big mass that we're looking for to have on the bottom. So we have mass on the bottom as well too. Okay, but it's not the right units because I want micrograms per kilogram. So, okay, so I want to change my drugs into micrograms. How can I change my drug into micrograms? I make this a little bit bigger. So I have more room to write.
divide that by 1,000?
Ah, so you're telling me, so let's clarify so that we're not doing crazy stuff. So you're telling me that 1,000 micrograms equal 1 milligram. Is that what you're trying to tell me?
Yes.
Okay, so then you're saying, so will we divide this number by 1,000, or will we put 1,000 micrograms?
I think at the bottom.
Are you sure?
Yes.
Well, because don't we want micrograms on top? Let me write it the way that you guys will understand, so it's not that funny looking. You. Do you want to put money on that, Mary?
I'm still trying to figure it out, actually. I'm kind of sleepy, so.
Okay, so we have milligrams right here on top, and we want to get into micrograms, right? MC, it's like the funny U.
Okay, MCG.
Yeah.
Okay.
And just so you guys know the record, 1 gram equals 10 to the 6 micrograms.
Yeah.
And 1 gram equals 10 to the 3rd milligrams. So then I could say 10 to the 6th micrograms equals 10 to the 3rd milligrams.
Yeah.
Or I can just simplify and say 10 to the 3rd micrograms equal 1 milligram.
1 milligrams, yeah.
Okay, so here's milli. Mil is on the top, and I want to get rid of it in terms of units because I want micro. So shouldn't I put that on the bottom here?
Yes, you should.
Okay, so then that allows me to cancel these units out, right? So now on top, I have micrograms, which is what I want. I want it in micrograms. Okay, so milliliters cancel each other out. And so now I'm left with micrograms, hours, pound. But do I want hours?
No.
What are the units I want?
Minute.
You
I want
want,
minutes.
you want minutes.
Okay, so how do I convert to minutes?
You want to convert an hour to minutes.
Okay, so how do I do that?
1 hour on
60
top.
minutes
24 on the top and 1 day in the
is 1
bottom.
hour.
Okay, so I heard somebody say I have 1 hour on top,
And 60 minutes on the bottom.
and then how many minutes are in an hour?
60
Oh,
minutes.
60.
Right? So we don't want to put days in there, right? We're not
No, not
about days.
Yeah.
We want to get rid of those hours and change them to minutes. So now we have minutes on the bottom. Isn't that what we're looking for? We want to have minutes on the bottom.
Yes.
Okay, so we accomplished, let's see, we've got micrograms on top and we have minutes on the bottom, but we still have those pounds. How do we get rid of those damn pounds?
I think
1
how
pound
many
Can
pounds
I
are in
do
1 kilogram now?
and 2.2, or is it 2.2 kilograms?
Yeah, I think 2.2 pounds in a kilogram. Or,
Yeah.
2.2 pounds in a kilogram.
Okay, so we said 2.2 pounds per 1 kilogram, right? We're gonna put that, are we gonna put pounds on top or
Yeah.
pounds on bottom?
Pounds on top.
Okay, so we're gonna put our 2.2 on top
Okay.
and 1 kilogram on bottom.
Dr. Henry, does it matter if you put 2.2 or 2.0? It doesn't matter?
It does matter a little bit. So if you put 2.0, your number's going to be a little bit off, but it's like 2.205. So if you just put 2.2, it's pretty good. But if you look at your sheet, depending on where you look at, it'll say 2.2 or it'll say 2.0. So I'd always
Yeah, that's
go
how
for
my
that.
sheet says.
Yeah, I always go for the 2.2, and I kind of ingrained that in my head. So
All right.
okay. So then that gets rid of our pounds, right? And we've got the units that we want. So then now, since we got the units that we want, we could just multiply across. So here's a hard question for you. How many sig figs should I have?
Okay. Sig figs. Well, is it do we pick the number with the highest sig fig or the lowest?
That's a good question, but here's the question I'm going to ask you. So are these equivalencies or are these givens?
Okay, I would say they are givens.
Are you sure?
I'm not, obviously.
They're equivalencies.
They're going to be considered equivalencies. Anytime that you typically see milligrams over milliliters or things like that, they're typically considered to be equivalents.
Okay.
Right?
Okay.
And so in that case, we're not going to take those into consideration. So the only thing that we should be taking in consideration is
the
pounds, right? So if we're doing that, then how many sig figs should I end up with?
Okay, 3.
3. Okay. So what did you guys get? While you guys are doing all your calculations, I'm going to see if I can fix the assignment so you guys will be able to take advantage of this free answer. Although you may want to pay attention because they switch some of the numbers to keep you guys on your toes. So it may not be 135 for you. It may be, oops. So I see 6.5, 6.52. Aaron, what did you get?
I forgot to round up in my original text, but I got 6.52.
Okay. So piece of cake? What do you mean by
How do you punch that in when you're doing the?
I don't think anything is really easy. Everything is hard. Like you have to really put effort.
Okay. So how you're asking me, how would I punch that in my calculator?
Yeah.
So what I would do, I put in 600 times 20 times 1,000 times 2.2. And then I then go divided by, then I go 500. And then I say divided by 135. And then I say divided by 60. Okay, there we go. Israel's going to get mad at me. Okay, questions, concerns, cash, credit, Crayolas.
Cash sounds good.
Okay. It always sounds good when other people are providing it, right?
Yeah. Well, I'm starting to get the hang of it now. Just need more practice with it.
Yep. And this one is a challenge one. It kind of catches you off guard, right?
Yeah.
Okay. So you guys should have access to it for an additional day. So it'll be due tomorrow night. So if you didn't get a chance to finish up, finish up.
Okay, does that mean I can
I'll throw in a couple of extra attempts because I know that some of you guys kind of got caught in the in-between.
Oh, thank you.
Let me see, maybe. Come on.
Does that mean I could ask you the 2 or is it the 3 questions I have?
I'll do one. That is the deal. Although there's a lot of comments in the chat. Let me see what they have to say in the chat. So I'm going to try to be fair. Let's see.
Okay.
Yeah, so you guys can do it either way. They should all actually work out both ways.
Okay, Dr. Henry.
Yep.
In my Chem 101, it's still saying time's up.
Okay, let me see why. Give me a second. So what you want to do is refresh, hit refresh, the refresh button.
Yeah, I just did that, yes.
Okay,
Okay, thank you.
no problem.
Okay, so I could share my screen now.
Okay, so I'll stop sharing mine.
Okay.
Okay, let's see.
Excuse me, please. Okay. I tried this one so many times, I just couldn't get it.
Okay, so let's figure out what you're starting off with, right? So what we're going to do is, what are you given there?
Okay, I'm giving 22.3 gallons.
Okay, so do me a favor. I'm going to write on your board, right?
Okay.
So you should always start with your given. So this guy is going to be your given, right?
Okay.
So look what you started out with. That's your density, right?
Yeah.
Okay, so you're starting off with your density, and then also you're just starting to make up units. You're saying that you have 22.3 grams, right? Because G stands for grams, it doesn't stand for gallons.
Okay.
Okay, and then you just magically put, 23.3 grams over 1 milliliter. That doesn't work. Does 22.3 gallons equal 1 milliliter, or does even 22.3 grams equal 1 milliliter?
Okay.
Okay.
Yeah.
So you always want to start with your given. Other things like equivalencies, density is kind of like an equivalent, right? So that we're going to be using a little bit later on. So what you want to do is you want to drag this guy at your starting point. So what you can do is just literally just go up here. You can just drag it from the top, from the question.
What?
And then, yeah. And then you want to drag the gallons, right?
Okay.
And so you want to get rid of that.
Okay. Yeah.
Okay, good. Okay, so that's your starting. And it's always good to start with what you're given.
Okay.
Occasionally you can't. Like the last problem we did, that's a little bit more complicated, so we actually ended up starting out with the weird how much drugs we're getting. And we just kind of use the units to work us there. Okay, so what is it that I want?
Okay, we want the mass in kilograms.
We want the mass in kilograms. Okay, so what are gallons?
Gallons are units for volume.
Gallons are unit for volume. Okay.
Yeah.
So if we look at this, right? Density.
Yes.
Equals mass over volume, which is an equivalency. Okay.
Yeah.
So this guy allows us to sit there and use density as our nice little equivalence. It gives us mass over volume. But first, we need to get into the right type of mass and the right type of volumes, right?
Okay.
So right now we are in gallons, but we need to be in grams, milliliters. So how can I go from gallons to milliliters?
Okay, so I don't know this stuff often. Actually, Dr. Henry, how do you cram all this conversion unit? Because I actually know only a few and I don't know how to know more.
So I print out my conversion sheet, and then after I print out my conversion sheet, I just start using it. And the more you use it,
Okay.
the better it tends to be. Okay. The more you'll start remembering it. Okay. So like, for instance, I know at the top of my head, and it's also because I think about things a whole lot. I know that 1 gallon is about 3.785 liters.
Okay. So I'm
Not
trying to check.
milliliters, but liters. 3 points.
Okay.
But if I did want to change it to milliliters, I could say it's 3,785 milliliters. But I like to work my way through it, you know, because I like to remember what milliliters are. So how many milliliters are in a liter? Mil.
Okay. Mil. Okay.
1,000.
1,000. That's right.
1,000. Okay.
1,000 milliliters are in 1 liter.
Okay.
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 Okay. So then I got my first couple of equivalencies, right? So I know I'm starting with gallons, so I want to get rid of gallons, right? So then what do I need to put on the bottom to get rid of gallons on top?
Okay. You want to get rid of gallons. So to get rid of gallons, you have to put 3785
Okay, you do it.
milliliter.
Show me, and then talk as you show me. It's a kind of a thing, right? So drag your 3.785.
Okay.
So is that going to be on the bottom or is that going to be on top?
Okay, just give me a second, please.
Sorry, I get anxious.
Okay, that should be at the top.
Dr. Henry, do you remember this the other day? What happened to me as well?
Yep.
Yep.
Okay, I guess at the top. One gallon.
Okay. Looks pretty good so far, right? So then don't we also have our next conversion, because then we have liters and we want milliliters, because then that's going to help us use our density, right?
Yes.
So if I want to get rid of liters and change it to milliliters, what do I need to do?
You'd have to multiply by 1,000.
Okay, so you go ahead and drag and drop. I love this program. You can do it in a toilet and everything. So.
Okay.
Is that right? Because don't you want to get rid of liters? There we go.
Yes.
There we go. Okay.
Yeah.
Okay. So now that we've gotten rid of liters, so we're given also this nice little equivalency that says 0.8206 grams per milliliter.
Yeah, grams per milliliter. Okay.
Okay.
Grams per milliliter. Okay.
So.
Okay. So I guess next we do is how come I do? Is this it?
Beautiful. Good job.
Okay.
Okay. So now, well, I guess you're good. Now all you have to do is multiply, right? Because everything else is right. Because now you have kilograms, right?
Okay. Well. Okay. If you could see the fourth conversion factor and all that stuff, I think I got it wrongly. This I have to delete it. Like,
no, you don't. You're actually fine. You just got to put the correct answer. So you had
are
it
you
right.
serious?
Yeah, you had it right.
Okay.
I carried away.
I don't know how I got that right, actually.
Yeah, you did. Actually, you need to put that back, the one that you just had. So put in the add factor, right? And take a look at the units. I mean, if you go through and do your unit analysis, it tells you that you're on the right track, right?
Oh, okay. Actually, I know I got that right now. Okay, so let's see.
Like you had 1,000 down here.
Okay. That is, I'm changing it to
kilogram, right?
Okay. Changing it to kilograms.
Okay. So then you canceled out your grams.
Okay.
And so you guys know that 1,000 divided by 1,000 is going to cancel out. So this is a real easy one, right? So you just multiply
Okay.
22.3 times 3.785 times 0.8206. Then you get your answer.
Okay. Okay. Excuse me. I'll have to calculate this now.
Okay, so do you guys all see that? Do you see how like you break it down and you break it into little segments? You have to remember those equivalencies, right?
Yes.
So Andrea asked, how did she get the 0.8206 from? Well, it comes from the problem. They gave us the density, and that's a nice little equivalency. Density always allows us to convert grams into milliliters. Gives us that, how we can do grams into milliliters. Brianna, how's Mexico?
Can't find glow sticks over here. Like, I was gonna bring some, but I wasn't sure if they would like let you take them on the plane.
Yeah? Is it hot or is it?
Yeah, it's really loud here too, though.
Oh, okay. I meant to send you an email. I just gotten busy, so. Okay, so let's get back to the lecture. How about that? Are you guys feeling a little more confident?
I feel it.
You feel it? Good.
Yeah.
More practice, though, but I got it. I'm starting to get the hang of it now.
Yeah. And it, you know what's really cool? It's like a puzzle, right? And if you look at it like a puzzle, you can sit there and use units to sit there and try to figure out everything. It's really cool. It's like the coolest thing ever.
Right.
You know? Okay, so let me clear all my handwriting and then I'm gonna take over again.
Okay.
Yeah, you know, Cole used to sit there and just do problems like this for fun, you know, just like they make up stuff and then things like that. So I'm gonna kind of skip some of these. You guys can look over the lecture notes, right? Because some of them are kind of just, you know, they're easy. You guys have done the hard ones already for homework, right?
Mhm.
Good. Okay, so Cole had talked to you guys about SI units. So you want to be familiar with SI units because in science we use SI units, right? So you want to be using kilograms, grams. And I know it's hard for us in the US because we're like, damn, I know pounds, I know feet, I know inches, but I don't know no damn grams. And, you know, but we need to start learning how to do that. We need to be malleable, flexible, adaptable, right? And we are in a global society, so we need to be able to sit there and be able to convert our crazy units into units that are kind of normal, right? And so the other thing is that there is so much beauty in the metric system. One of the beautiful things about the metric system, it's based on 10. So it makes things a whole lot easier rather than how many feet, how many inches are in a feet, in a foot?
That's 12.
Oh, how many foot are in a yard?
Is it 3?
3.
How many yards are in a mile?
Wait, what was that again?
How many yards are in a mile?
I think that should be 13 point.
1,760.
It's like 760 something, right? I mean, me and somebody had figured this out the other day. I Googled it. I was like, I don't know, right? Does it make sense though, right? Is it multiples of 10? Is it easy to remember?
Yeah.
It is easy to remember?
Wait, what'd you say? What'd you ask?
I said, is the United States the Imperial System? We're using the Imperial System. And it's called the Imperial System. It should say, it used to be called the Imperial System because it was based upon a king, right? His foot, you know, and his inch, the width of his finger or something like that, you know, so it was all based upon him. And so our units don't make a lot of sense, right? They're not nicely even. Where the metric system is based upon 10. It's based upon 10. It's a lot easier, right? And so it's easier to remember. So a lot of the units that we're going to be using are going to be in the metric system. So it's going to be based upon 10, right? Because we know that in a gram, well, 1,000 milligrams will equal a gram, right? 10 base. 100 centigrams will equal a gram. 10 decagram will equal a gram. It's all based upon 10. It makes it so much easier. But then we have what we call our base units. We have our mass units. Mass is grams. Volume is milliliters. Mass is volume. Distance is meters. And so we kind of use that to sit there and do it. And so once you have your base units, you just apply those abbreviations, those prefixes to sit there and determine how big it is, right? In terms of the metric system. And I'll show you that here in a second, I promise. Can you guys see my screen? You guys see the metric system? Yes, no, maybe?
Yes.
Yes.
Because sometimes I'll just be talking and I'll just keep talking. So you need to be familiar with those prefixes. And so somebody asked me, because they're kind of funky, right? You can't remember them all and stuff, but there are ones that you should definitely know. You should know a centa, century, right? That reminds me of a centa. Century, centa. So century is how many years?
100.
100. So we know that centimeters, right? So 100 centimeters will equal 1 meter. Okay. And I talk to you guys about mil all the time. Most of you guys are Spanish speakers. And if not, you're going to be one by the end of this class, right?
Why?
And we know that mil means 1,000, right?
Yeah.
In Spanish. Does it not? Or am I making stuff up?
It does.
It does. Okay. So somebody didn't lie to me when they taught me that. When I fixed
That rhymes when it's 1,000 millimeters, millimeters.
Okay. So
Kinda right.
micro is going to be 10 to the 6. And let me show you this. I have this nice little table here. So a micrometer, right, is going to be 10 to the 6 meters. Or these guys, the way that they're written, are written a little bit backwards, kind of weirdly. So a micrometer, right, is going to be, what was that?
I didn't see anything.
Okay, so a micrometer is going to be 10 to the, it's going to take 10 to the 6 micrometers to equal 1 meter, right? Or you can sit there, and the way that they have it written is that 1 micrometer is 10 to the minus 6 meters, right? So this is like saying meters, guys. Okay. Nano. I remember nano because of 9, right? 9. So it's 10 to the 9th nanometers will equal 1 meter, or 1 nanometer will equal 1 nanometer will equal 10 to the minus 9 meters. So they're equivalent. And pico is 10 to the minus 12. I don't know how I remember that one. I was just kind of sticks for some reason. Deci, deca, a decade. How long is a decade? How many years is a decade? 10, right? So deci reminds me 10. So I know that 1 decimeter will equal 10 to the minus 1 meters, or 10 decimeters will equal 1 meter, right? Okay, and then that's the same thing here when we start talking about deca. Deca means 10. So 10 meters will equal 1 dam, right? Which is decameter, right? Are you with me? Okay,
Yeah.
so the ones that you should definitely know are kilo, centa, milli, micro, and I'm going to make nano. Okay, mega, yeah, I guess you should know mega. The other ones, they're probably going to be given to you on the exam, okay, or on a homework assignment. And if they're not, you guys can print this guy out and have it for your benefit, right? Since all those slides are available. Okay, so we have mass, right? Mass and weight. So since we have mass and weight, right? The difference between mass and weight is dependent on gravitational force. Okay? And you're going to get a question like that. I always give a question like that. And I always have about half the class remember it, another half class that doesn't. Okay. Mass is just going to be the measurement of quantity of that matter, right? So the mass, right? The weight is it's going to be the measurement of the force of gravity on a body, right? So since the gravity on Earth is different than the gravity on the moon, would you weigh the same on the Earth as you do on the moon?
No.
No, you wouldn't, right? But if I asked you the mass, is your mass the same on the Earth as it is on the moon?
Yeah, it's the same.
It will be the same, right? Okay. Simple. Okay. So we also, the units that we use for mass, kilograms, grams, milligrams, micrograms, nanograms. Okay. We also have length, distance, right? That's going to be meters, kilometers, centimeters, millimeters, nanometers, micrometers, right? And usually the way it works is that if we're talking about small distances, right, we're going to be using centimeters or millimeters. Or if we're talking about really, really small of distances, then we're going to be talking about nanometers, right? So like when we talk about wavelength and stuff like that, sometimes we're going to be using nanometers. Nano means what again?
10 to raised to minus 9.
So 1 nanometer will equal
10
to the minus 9th meters, right?
Yeah.
Okay.
Yes.
Okay, so we also talk about volume. So there's a couple of ways that we can do volume, right? If we're talking about SI units, we can use cubic centimeters, right? Cubic centimeters, CCs. You guys used to watch, any of you guys used to watch, what is it? Grey's Anatomy or is that other show?
No, sometimes.
So, or House, yeah, exactly. 5 cc stat, right? So what are 5 cc's? Well, cc stands for cubic centimeters, right? So cubic centimeters is the same thing as cm cubed. So 1 cubic centimeter is the same thing as 1 cc, right? Which is just happens to be the same thing as 1 milliliter. Okay, so 1 cc is the same thing as 1 milliliter. Questions, concerns, Cash? So that gives me this nice little conversion factor, right? So
Cubic centimeters are smaller than centimeters?
no, centimeters, cubic centimeters is looking at space occupied. So it's looking at a cube of space. That's cubic centimeters. Where centimeters is just distance. It's single line, right?
Yeah.
So one we're looking at volume and one we're looking at just a single line, right?
Right.
Do you understand the difference between the two?
Yes.
Okay. So I can use centimeters to convert, let's say I have inches. I know how many inches will equal, or how many centimeters will equal an inch. Does anybody know? Anyone?
2.54?
2.54.
How many centimeters will equal what?
Pardon me?
I didn't get the question. How many centimeters will equal what?
I said, how many centimeters are in 1 inch?
Oh.
Yes. Okay, so 1 inch is 2.54 centimeters, right? So I can use this to sit there and change cubic centimeters into cubic inches, right? Because, oops, I know that 1 inch, right? If I decide I'm going to cube it, and cube it, it's going to be equal to 2.54 cubed. And then that would be cubic centimeters, right? So I can sit there and use the conversion for distance if I cube it to make it into a volume. You guys get that? So I know you guys had like 50 problems that were like that on the practice. Right, Alan?
Right.
Okay, so let's see, let's move on. So we know kilograms are typically the units that we use for SI units. Well, again, you're probably going to use that, and particularly for larger quantities. And we know that 1 kilogram is equal to 2.2 pounds. You guys remembered that today, so I don't even have to tell you. Oops. And then we just talked about an inch. We're ahead of the game. Okay, so we've talked about volume. Okay, and so the beauty of the metric system is that we can always sit there and use that as relationship, regardless of what those units are. So whether it's a mass unit, whether it's a volume unit, or whether it's a distance unit, right? We always know that whatever those units are, 1,000 of those units will equal 1 kilogram, right? Or 1 kilo of those units, so kilounit, right? So we always know that conversion, where 100 centa will always equal, centa units will equal that unit, okay? So that is the beauty of the metric system, right? Are you feeling it? Are you with me? Mary, you with me?
Yes.
Okay. Let's see. So how many grams are in 0.711 kilograms? Nate, help me out here. Ooh, awesome. Go ahead, Christina. So how did you do that? So typically we're just going to start with our given, right? kg. And then what is the conversion factor? How many grams are in a kilogram?
That's 1,000. 1,000.
So 1,000.
Yeah.
Okay, for 1 kilogram. Okay. Thank you, Christina and Mary. Okay, so then that means all we need to do, so that's 1, 2, 3 zeros. So I can just move my decimal point over 3 zeros. 1, 2, 3. So then we get 711 grams. Piece of cake?
Yes.
Yeah.
Okay. Okay, good. Okay, so similarly, you could sit there and change your milligrams into kilograms, right? So what was the conversion for milligrams?
1,000.
1,000. So 1,000 milligrams equal 1 gram. And then that's a milligram. And then how many grams equal 1 kilogram?
1,000.
1,000? So I can use both of these equivalencies to sit there and get to where I want to be, right? So 5.25 times 10 to the minus 5 milligrams. So if I want to get rid of grams, am I going to put milligrams on the bottom or on the top?
The bottom?
Bottom?
Bottom. So I put my 1,000 milligrams on the bottom. And then I put my 1 gram on top. So that gets rid of, oops, sorry, that gets rid of milligrams. Getting ahead of myself. So if I want to get rid of grams and change it to kilograms, am I going to put grams on the bottom or on the top?
Grams at the bottom.
Okay, so I'm going to put my 1,000 grams on the bottom.
Yeah.
And then I'm going to put my 1 kilogram on top. Okay, so I have 1, 2, 3 zeros, 4, 5, 6 zeros. So then I would have 0.525 kilograms. Piece of cake?
I
Good,
got
bad,
point.
ugly?
I got 0.525, but it's the same, right?
You got 0.525?
Just 0.525.
Yeah.
But it's the same.
Yeah, because I just use that 0 to remind me because I'm sloppy. And so I always like to put the 0 in front to remind me. So that's the same thing as 0.525.
Right.
Okay, questions, concerns, catch. I like that. Can we do more problems like this? No, you got to do more problems like the homework. The homework is to challenge you, right?
No, not this. I mean the ones on the homework. Where can we find more problems similar to that of the homework?
I can see about putting a couple more practice problems on your homework. So they'll just be practice stuff.
Oh yeah, maybe you could put it like in the modules. These are, yeah, I just need more practice on these.
Okay. So we have a fruit drink is sold in bottles that contain 1,892 milliliters. Express the volume in cubic centimeters and in liters. So if I wanted to change this into cubic centimeters, how would I do that? If I wanted to change this into liters, how would I do that? So let's start with the cubic centimeters. So I have 1,892. That's my given. And I want to change it to cubic centimeters. How many cubic centimeters will equal a milliliter?
First, how many centimeters in a liter?
Okay, so I will ask you this again, right? Because didn't we just talk about this, Mary? You're telling me, you're saying how many centimeters? Centimeters. Does centimeters gonna equal milliliter? Is that true? This is distance. Look at those units. Centimeters is just distance.
Oh, okay. Well, I was thinking that maybe if you like this centimeter equals liters, then you could just do the cube of it, stuff like that.
No, because they're not the same unit.
Okay.
Centimeters is distance and liters is volume. So you can't do that. So we just talked about that. So what am I going to use?
Okay. Cubic
So what
centimeters
did
per
I say
liter.
earlier? Anybody remember what I said? So we want to definitely always pay attention to the units that we're using. So cubic centimeters, isn't cubic centimeters volume?
Yeah.
Yes.
So we already have it in here. So what is the relationship between a cubic centimeters and a milliliter?
Volume of 1,000.
Are you sure? So I have how many cubic centimeters will equal 1 milliliter?
1.
1.
1. That is correct. So they're exactly the same. They're both 1, right? So if I want to change this into cubic centimeters, just to show you, 1 ml, 1 cubic centimeter.
Okay.
Oops. Okay, so if I also wanted to change this into liters, what do I need to do?
1,000 milliliters in 1 liter.
So 1,000 milliliters.
1 liter.
Mil equals 1 liter.
Yeah.
Okay, so what's going on top? What's going on bottom?
Okay.
1,000 milliliters
1,000
on the bottom.
milliliters at the bottom.
On the bottom.
Yeah.
1 liter on top. So we get 1.8.
892.
92. Piece of cake?
Easy.
Okay, so we've already talked about sig figs. You guys should know this like the back of your hand, right? So, and if you just need that little bit of memory, you know that, so you can go ahead and read over the notes. Okay, how many sig figs do we have here? This first one.
3.
That is correct. What about here? The second one.
Okay, Dr. Henry.
Yep.
I don't get how it's 3.
Because
Actually, I was going to say 4.
it's 3 because right now it's just this one. This is called a leading zero, so this guy is not going to count.
Okay.
So leading zeros don't count.
Okay.
Okay. So what about here?
Okay. Well, here we have 5.
These are all leading zeros, Mary.
Oh,
What did I
okay.
just say about leading zeros?
Okay.
Oh, you're right. It's 2. The correct answer is 2.
Okay.
So this guy is 3. This guy is 2. Okay. So what about this one?
Four.
4.
Okay. Piece of cake.
Yeah.
Okay. We've talked about 5, right?
Yeah.
Yes.
Okay. The rounding. Okay. And you guys, I know that Cole did this with you guys, so I'm not going to do it again. But you can look it up on your own. Is that Kobe beef? Okay, so these are some of your conversion factors for the Imperial System or the United States customary system, the ones that we use. And so you guys want to be familiar with it, but you guys also have your conversion sheets. Okay. So the other thing I wanted to talk about before we go is temperature. Temperature is very, very important, right? It's going to be very, very important in chemistry. A lot of times we use temperature in Celsius in chemistry, but we also use another type of unit. It's called Kelvin. So you guys are familiar with Fahrenheit. That's what most of us use in the US. We use Fahrenheit. The rest of the world uses Celsius. So this is the conversion Fahrenheit versus Fahrenheit into Celsius. And then if you guys look on your conversion sheet, you actually have this. So this would be the temperature in Fahrenheit to get this temperature in Celsius. So if we wanted to solve this equation for Celsius, for Fahrenheit, we'd say TF equals 1.8 TC plus 32. Okay, so this will change Celsius into Fahrenheit. Okay, so the way that I always remember this is because I know that 100 degrees Celsius is the temperature that water boils at, which happens to be 212 degrees Fahrenheit. So I always check my answer by doing that. So let's put in 100 degrees in this equation, or 212 Fahrenheit for this equation. So 212 minus 32. So that's going to equal 180 over 1.8, which equals 100. So if I do the same thing and I put 100 degrees Celsius, 100 degrees Celsius in here, so then that's 1.8 times 100 plus 32, and that's going to equal 212. Or I also know that water freezes at 0, and then that's usually negative 32 degrees Fahrenheit. So that's another way that I can sit there and make sure I have the right equation. Okay, so all it is just plugging into the equation. Any questions?
Nope.
Good. So the other temperature that we're going to use, and you're going to use it a lot in chemistry, is called Kelvin. We use the Kelvin scale because the Kelvin scale at 0 degrees is absolute 0, right? And that is going to be, that allows us to have this equation. So T Kelvin, the temperature in Kelvin, is going to be equal to the temperature in Celsius plus 273.16. So usually you have this 0.16. Okay. So this allows us to sit there and convert to Kelvin. So if I have 15 degrees Celsius, then my T Kelvin is going to be 15 plus 273. And if you want to be more exact, you can put the 1.6. So then it would be 288.16. Piece of cake?